Okay, so recording is on. Look at here. So for example, if we want to display E, so what are the segments we have to put, we have to make on? So A must be on, B, okay, so different color, I can use different color. So A must be on, but B and C off. All other segment off are on, and dot point also off. So dot point is 0, B and C, they are 0. So what is the in hexadecimal code? It's 7 and 1001. So that means 79. 79 hexadecimal number if to display E. And for O, we can see that all the segment on except G. So look at here, G is off, and also as well dot point. So that means it is 03. It's like that. So that means to turn on an LED, a segment LED like A, B, C, D, we are sending one. So this is actually for common cathode system actually. So basically we are using mostly this common cathode system is used because here all the cathodes are connected to the ground, common and ground. And if you send one means 5 volt. If you send 5 volt here, this A LED is on. If you send 0 here, B LED is off. It's kind of like that. So this is one way, and there is another way. It is called common anode system. So common anode system, all the anodes are common and they are connected to VCC, 5 volt for example. And now if you want to turn on this A LED, A segment LED, you have to send 0 here. Then there will be a current flow and this LED will be on. And if you want to keep B off, you have to send 1 here. So 5 volt. So 5 volt, one side 5 volt, another side VCC. So there will be no current flow because same voltage on the both sides. So this is like that. Is it okay? Do you understand this one? This already I say in the last class. So common anode system means to turn on any LED, we have to send 0. And to common cathode system, to turn on any LED, we have to send 1. 1 means 5 volt. Then it will be. So this is for normally. So this one is common cathode system. So common cathode system, and all the cathodes are connected to the ground. Common point is connected to the ground. Okay, so now this is about more details about the circuit. You can see that if we send a 0 here, then this LED is turned on. Now we can work on this one. This is active. And if you send 1 here, so that means this one actually make this transistor off. And so that means this LED is actually inactive. So kind of like that. So we are not actually going details about this circuit. This is just for information. Okay, now look at here. For example, we want to display UOHB 2017. What is the code for U? We can if we make a table like that, you will get the code for U, for O. So O already is here. One of the example 3F. Or H, B, 2017, so on. So these are the code. We put it in a table. All right. Like for U, for O, for H, B, 2017, kind of, so on. And what are the address? For example, addresses are given here: 0001, 02, 03. And what is the control word? Control word is that if this is the control word, 8-bit control word, and here port A and port B use, and both are output port. You can see both are output port. So both are output port, and this one is actually, so this is for port C lower, it is don't care, and port B output, and mod 0, and then port C upper, this is don't care, and port A, this is also output port, and this 2 bit is for mod 00, and then MSB bit is 1 active. So if don't care cases are 0, that means it is 80 hash. Okay, 80 hash, or if don't care cases are 1, it becomes 89 hash. Both are okay. Okay, this is about the control word. Now we can write it dot mod array small and dot code, and then move al comma control word. Control word is sent to the control register. What is the address of the control register? For example, 03H. Here it is given, for example. Okay. Yeah. So these are the things they given. Now we said move, yeah, move BL comma 8. BL comma 8, it is for, I mean, let us see what is it. So move SI comma offset table. So that means for you, the address, offset address of you, offset address for the first line, this one is, we set it on SI. And then move AL comma 0, 1, 1, 1, 1, 1, 1, 1. So all the bits are, all the digits of the 7 segment display set, they are inactive. Just only keep active for this digit. You can see this first figure. We look at here, for example, here. So to active this one, we have to send 0 here, right? So that means all are 1, this one is 0. And then we will send on this through the port A, we will send data for different segments, A, B, C, D, E, F, G, and dot point. So look at here. So move AL comma 0, 1, 1, 1, all the bits are 1. And out, where actually we send it? We send it to the port B, because we have to send it to the port B. B is controlling the digit. And then this one, because we have to use AL for another purpose also, for sending A, B, C, D corresponding data. So that's why this AL data we put it in AH, so that it is not lost, or it is not overwritten. And then move AL comma square bracket aside. Now look at here, we are using the AL again to get this the ABCD EFG, the segment data for U. We say we keep it in AL, and then out port A comma AL. So that means now the U is displayed. So U is displayed now on the first one. Then we have another set. So here it is U. Then we have another set, another display, that we have to send O here. Okay, O here. So first of all, but now this one is active, but all are inactive. So that means we have to make the rotation of these data, 0, all are ones. We have to, so and between the each digit there should be a delay. Like for example, it is 100 millisecond delay. So we call a 100 millisecond delay, call delay. And here is a delay subprogram for like around 5 megahertz microprocessor. The number for 100 megahertz is 27,300 around. What actually we use in the lab. Okay, so it is, we already know it, 27,300 approximate. Okay, so this is the 100 millisecond delay subprogram. Then increment SI, we have to go to the next for next data, right? Increment SI, and then rotation right AH comma 1, because AH has this data 0, all the ones. Now if you do the rotation right, so this now all the things will be 1 and this one will be 0. All the things are 1. Okay, and move this AH to AL, this data 12, because we have to send it to the AL. I mean, we have to use the AL to send it to the port B again, and decrement BL, because the BL, how many times we will do it? 8 times. That's why we use a counter BL. Using the BL, we decrement BL, or you can use a loop here also. Loop here, and then loop repeat. So you have to do it repeat here, and then jump start. So repeat is actually, I said you repeat should be here in this line here. Here repeat. Otherwise, actually, so because after the rotation of the bit, we have to send it to the port B. Repeat is here. Is it clear? Do you get it? Repeat is here. All right. Is it okay? Okay. Loop repeat. So instead of these two lines, we can write loop repeat. Okay, and then once it is done, then jump start from the beginning, or we can write the start here also. Jump start level here, because you know that control word, we don't have to do it again and again at the beginning, because there is no change in control word to the control register. Okay? So we can write it here or at the beginning where it is now. Okay, so this one, do you have any question here? All right. So then let us go for the another example. Another, it is stepper motor. So stepper motor is control of the stepper motor. So first of all, I think all of you have the idea about the stepper motor. If it is not, actually it is part of the machine. So I am not going details. To describe details about it. But what is the stepper motor? You know that it is operated. It operates in a step. It's not continuous rotation. It is a step rotation, like a DC motor. So DC motor, when actually it is moving continuously in an angular way. But a stepper motor is like that. There is a one step, then second step, then third step, then fourth step, fifth, sixth, kind of like that. So it is not a continuous rotation, it is a step rotation. Okay, so depends on the depend on the signal, because it has many phase. It's not just only single phase system. It has a like 4 phase, 6 phase, 8 phase system. So depending on the different signals, it moves, it steps, it takes, it jumps from one level to another level. Like for example, here at 0 degree it is, then for example 10 degree, then 20 degree, 30 degree. So complete rotation is 360 degree. Okay, so it jumps from one step to the next step. Okay, and step angle also varies. So as I said to you, from 1 degree to 15 degree, depending on the how much precise we need it. So like if you think about the printer, dot printer, you can get it very nicely. You can see that dot printer is actually, it just like making a jump, 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 kind of like that. Even though it is not a angular rotation, linear rotation, but it works that way. Okay, so that means it's not continuous, it's a step. It jumps from one step to another step, and this step angle, it can vary from 1 degree to 15 degree until according to the precision. I mean, how much precise it is, like according to the DPI, dot per inch. How many dot you, I mean, how many data you want. Like for example, if it makes 1 degree 1 degree, there will be jump like that. But if it jumps 5 degree 5 degree, so it will be like that. So that means it actually missed some information between the gap. So that's why we do not want it. We want that it should be good, or DPI should be good. Dot per inch, it should be good. So that means we need a less number. I mean, angle, step angle should be small as possible. Okay, so this is the idea. So this is a stepper motor. That means it doesn't rotate, or it doesn't move continuously. It moves in a step. Okay, so discrete, or you can say it rotates in a sequence of discrete steps, or I mean discrete, because they are not continuous. Is it okay? Do you understand it? Steps. So this stepper motor idea is okay. So if you look at here, okay, if you look at here, for example, it is a four phase system, or 4 coil is there. If you look at here, and this is for example A, this is for example B, this is for example C, and this is D. So a complete rotation is 360 degree. Now for example, A and B both are active. So what will happen? So if both are active, means they are producing electromagnet. So if they are electromagnet, so this magnetic material, rotor is a magnetic material. So it definitely it is attracted by this coil A and coil B. So if something, I mean A and B, they are 90 degree apart, right? 90 degree. This is a 90 degree. So what will happen? The rotor will remain in the middle, 45 degree. So then B and C on. Sorry, A and D on, for example. Okay, let us change it. A, this one is B, this one is C, and this one is D. Or maybe, okay, okay. Let me write it again. So this is our stepper motor, okay, and this is, for example, this one is A phase, B phase, C phase, and D phase. Okay, so now A and B both are on. A and B, they are in 90 degree apart. Okay, if A and B, they are electromagnet, they are, by sending the supply, they becomes a electromagnet. So electromagnet, so actually what will happen, the rotor is a magnetic material, it will remain in the middle here. This is 45 degree, for example. And then B and C on, B and C, these two on. What will happen? It will jump from here to, it will remain in this angle. So this angle is 135. And then C and D on, what will happen? The rotor will move here, another 90 degree. So another 90 degree, it will be 225. Then D and A on, it will move, it will jumps here. So like it jumps 90 degree, and it at the beginning when A and B on, so it is in 45 degree angle. It is in 45 degree angle. For example, this A phase is the reference phase. This is in the 45 degree, and then 135, and then another 90 degree is 225. Then another 90 degree is 315. So it's like that. Is it okay? Do you understand this one? Clear? Is okay? So this is like that. So this is, for example, okay. So what actually we can write it in a simple format. Like, for example, we have a B, C, D. We have four phase system. This stepper motor is four-phase system, and two phase is on at a time. For example, this one is on and this one is on, but these two off. What is the angle? Angle. What angle the rotor remain? Angle. So if for this is A phase, B phase, C phase, and D phase. So this one is like that. So A phase is so, and rotor is in the middle. So if A phase is a reference angle, so this is the 45 degree. So we can write it 45 degree. When A and B both are on, it is in 45 degree. So when B and C on, that means all are off. B and C on, that means B and C phase, they are on, they are electromagnet. Then it will be in this angle. So this is, you can think about it. So it is in the middle. So it is 135. 135. When C and D on, others are off. It is another 90 degree jumps. Look at here, 45 degree to 135 is 90 degree. Another 90 degree, it will be 225. Okay, 202. Then D and A on, other two off, B and C off. What will happen? It will jump another 30 degree, it will be 300, another 90 degrees, so it will be 315. Then it repeat again. So if we make A and B on, A and B on, now A and B on again, what will happen? It will be another 90 degree. So 90 plus 315, it will be like 405. So 405 means 405 minus 360, it will be 45. So that means it will actually, this one is, and that one is same. So basically from this level to it repeat the things again. Okay, so that means, so this is the two-phase system. I mean, two-phase on at a time, A and B, both two-phase are on, then B and C, then C and D. So two-phase on system. So, and if it is a four-phase it has, so then what will be the step angle is 90 degree. So this is the basic idea about the stepper motor. So let us see more. So now look at here, how can you make two-phase on? How can we make two-phase on? Like, for example, this motor is connected to, okay, let us have a look. So if it is a four-phase system, okay, four-phase system, and port B is, so it is connected to, for example, port B, and four-phase, but each port is 8-bit. Okay, so it's 8-bit port. Port A or port B or port C, whatever it is. For example, it is port B, connected to the port B, and as it is a four-phase system, so A, B, C, D, they are connected here. For example, this one is this A, this one is B, this one is C, and this one is D. Okay, if it is like that, others are unused actually. but they should be symmetrical. What? Okay, now for example, A and B, they must be 1. They are turned on, others are off. Okay, so now look at here, C and D off, A and B on, C and D off. Then actually B and C on and other are off. Okay, then C and D on, others are off. Yeah, so it is like that. So that means you know that the unused bit, it should be symmetrical with this bit, this 4 bit. So what is the 4 bit here? 4 bit is 3, right? 0 0. At the beginning, we have to turn on A and B on. We are sending 3 here, 3 here. So that means this one also should be 3. So 33H. That means if we send the 33H, okay, to the port where actually this stepper motor is connected, then it makes the 2-phase on system. Why actually we send 3 here? Because you know, like for the second step, look at here, for the second step, when actually we make the, okay, let me write it again. So again, so for example, it is port B. Anyway, where actually it is connected, DC motor, and this is for A, B, C, D, and this 4 bit is unused. But what actually, so first of all, we for 2-phase system, A and B on and C and D off. So this one is just and also unused bit, we have to make it symmetrical. So it must be 0 0 1 1. So that means 33H. Okay, then what will happen? B and C on. This one is on. That means this one is off and this one is off. So same like here also. This one is off, this 2 on, and then off. So look at here. How can we get this second line from first line? Just we are shifting rotation. I mean, we are rotating this bit 1 bit. If you look at here, if you left shift 1 bit, this one will come here, this one will come here, this 0 come here, this 0 come here, and this 0 it will fill up here. So if unused bit is not symmetrical like the used 4 bit, unused 4 bit, so then we will not get this kind of I mean, we will not get this order or this proper bit here. Is it clear now why actually this unused 4 bit is same as like the used 4 bit? Clear this one? Yeah. So now look at here. What will be the next line? Yeah, you can look at here. What will be the next line? Next line should be A should be off, B should be off, C is on, and D is on. So same like here also, 0 0 1 1. So now look at here, this third line we can get it from the second line if we make a left rotation 1 bit. This 0 come here, this one come here, is so on, this one come here, and the 0 what is here, it will be coming up here. So that means if it is not symmetrical, this this 4 bit, if it is not symmetrical like ABCD, then it will not, we cannot, I mean make it proper order. That's why for two-bit rotation, I mean two-phase rotation, we must have to send 33H. Is that clear? Is it okay? And then what will happen in the next line? Next line, you know, D and A on, other two off. So same thing should be here. 1, 0, 0, 1. Same thing should be on here. And how can we get this fourth line from the third line? If you look at here, the fourth line, if just one bit left rotation, that means this is the this is said here. If the rotation left rotation AL comma 1. So if you send it to the through the AL, if you use the resistor AL comma 1 and then send it again. So then send it again. So it will be like that. So 33H, if you so that means first line is 33H, 33. Then it will be the second one will be left rotation one. It will be 66H, and then CCH, then 99H. And also, so what will be the angle? As I said you, for two-phase system, the angle will be, if it is a two-phase excitation system, and if there are 4 phases only, so every time it will jump 90 degree. So start from 45, then 135, then 225, then 315, and then repeat again. So this is the basic idea. Okay, so this, forget about this thing. Okay, stepper motor. Now look at here. For example, if you look at this circuit, so forget about this thing. This is actually Darlington pair transistor circuit. So we are not. This is the part of electronics. If you finish the electronic course, I think you know it, Darling pair. So anyway, so this is the stepper motor. If it is a 4-phase system, so A here, B here, and this is C, and this is D. Okay, so A, B, C, D. We only know that we have a B, C, D, and they are connected in a port A, port 0, port 1, port A 0 to 3B. Okay, so they are connected. So this is, for example, A phase, B phase, and C phase, and D phase. Okay, so 4-phase system. And what about the port B and port C? They are unused because stepper motor here they are unused. For example, here. Okay, so now it is like that, and let's see what kind of exercise it here. Okay. So now, if you look at here, yeah. So port A, port A is connected to the stepper motor. 4-phase system stepper motor. A, B, C, D, 4-phase system stepper motor. And each phase, for example, we want to turn on it in 2-phase excitation, like 2-phase or 1-phase. Let's okay. This is about okay. What happened? What about for the 1-phase excitation? Look at here. If it is 1-phase excitation, what will happen? What number we should send it? So this one is A, B, C, D. If it is a 1-phase excitation system, that means this one should be 1, this one should be 0, and this one should be 0, and then this one should be 0. Okay, and what about the other bits? So this one should be symmetrical. So it also should be 0, 0, 0, 1. So that means it is like a 1-1H. Okay, it is like a 1-1H for 1-phase excitation. Then what will be the next one? B is on, A, C, D is off. So same thing is here also. 0, 1, 0 and 0. Okay, so look at here. Second line is coming from the first line if we make the left rotation 1B. Okay, and then what will be the next one? C is on, other bits are 0. A, B and D 0. Okay, and same thing is here 0, 1, 0. So that means third line is from the second line, left rotation 1B. Okay, so then what will happen in the D phase? D phase D will be on, others A, B, C is off. Okay, and then same thing is here also. So that means fourth line is coming from the first line. Then again, it will be the first line. If you make it, I mean, if you make 1 bit rotation, what will happen here? 0, 0, left rotation, 1 bit left rotation. It will be 0, 0, 0, 1. So this one is the same as the first line. So 1, 1 H. This one is the same as the first line. Okay, so that means for one phase excitation system, what will happen if we have a B, C, D? Okay, and it's about if it is an angle, here it is an angle theta, for example, angle is theta. So if A is on, B and C all are off, what will happen? So the rotor is in the same axis of the A phase, same axis of the A phase it will be, because there is no, so it's not in between two phase, so it is 0 degree. Then B is on, C and D off. What will happen? It will jump 90 degree. As I said you, so here it will be 90 degree. Then because you remember, if for example this is our rotor, this is for A, this is for B. This simple drawing, for example, this is for C and this is for D. This is for D. And when actually A phase is on, so rotor will be in the same axis with A rotor. Then B is on, it will jumps from here to here, this axis. And then C is on another 90 degree, and then D is on another 90 degree, then A again, so it will jump another 90 degree. So it is like that, 0, 0, 1, 0, it will be 180 degree. So this is about the single phase excitation system, and previously we discussed about two phase excitation system, and each case it jumps 90 degree. All right, and if it is 0, 0, 0, 1, I mean D phase on only, it jumps another 90 degrees, so it will be 270 degree. 270 degree. And then again, first line, A phase is on, it jumps another 90 degree, it will be 360 degree or 0 degree. Is it okay? Do you understand this one, single phase excitation system? Single phase excitation system is okay, clear? So two phase, there are two things. One is two phase system, one is single phase system. And there is something in between, two phase and one phase, two phase, one phase. This is, I will discuss later. Okay, so now it's a, for example, this one is a the stepper motor circuit diagram. We can find the we can find the addresses of the ports using chip select signal and A0 and A1 easily. Okay, this is not our main thing because we already learned it. Now it's about, here only port A is used. Port A is connected to the stepper motor. And okay, let's have a look. what kind of program it is. So for example, the port A address is this one, port B address is this one, C and D. This is the about. And what about the control word? Control word is, this 8-bit control word. You can see 8-bit control word. So what will be the control word? Okay, now this one is for port C lower, it is unused. This is for port B, it is also unused, and this is mod 0. And then port C upper is unused, and then port A is the output port because it is connected to the stepper motor, and then these two are for mod 00, and this is 1. So what will be, if don't care cases are 0, it will be 80H, or if don't care cases are 1, then it will be 81011. So it will be 10. So B, 8BH. All right. So control word is both are okay. So now control word, we send the control word to the control register. Control register address is 2003H, and then move AL comma 33H. Look at here. So we have to send to the stepper motor 33H for two-phase excitation. Okay, this is we already discussed that, and then we will send it to the stepper motor because stepper motor is connected to the port A. So at out port A address comma AL, and then delay. There is should be a delay, 1 millisecond delay between the step. For example, we want to make 1 millisecond delay between the step, because okay, anyway, so 1 millisecond delay between the step, call delay. For 1 millisecond delay, you know that for 100 millisecond delay we have to load the counter 27,300. So for 1 millisecond delay we 273. Okay, this is the thing. And then rotation left AL comma 1, and then again repeat, jump, repeat again and again. So this is the this is about, yeah. So jump here, not jump L, and then if once it is done, yeah, so it will be the continuous process. Yeah, that's it. So is it clear? And here actually we can write the end. Is it okay for two-phase excitation? This is the two-phase two-phase excited two-phase excited stepper motor. Is it okay? Two-phase excited stepper motor. But if it is a single phase excited stepper motor, what actually you have to send here to the register? 1 right? Can you remember? 1H instead of 3H. Is it okay? Okay, so this is a basic idea about the stepper motor, because stepper motor, it is a I mean mainly it is a part of the machine, but basic idea I try to share it with you, how actually it works, basic idea. So I mean now it's about, actually in this course actually it's about the control stepper, if it is interface with the stepper motor, if it is interface with microprocessor system, how can we operate it? Two-phase excited system, one-phase excited system, like that. As kind of, I mean, as we already learned the DC motor, in the last lab. So it is a stepper motor that is also, we can now control it through the microprocessor system. So, all right. So yeah, I will discuss a little bit another application of the stepper motor. So let us 5-minute break and then we will start again. Okay. So now 5-minute break. We will start at 11:03. Okay. Okay, so welcome back. Let us discuss stepper motor more details with another example. Okay. So what I'm writing here, you can use this one as a whiteboard. Okay, so look at here. Here we can discuss cases like a four-phase stepper motor is connected to the port A, and which bit are used? It is written here PA0 to PA3 because four-phase. So other four bits definitely unused, and two switches like S1 and S0, they are connected to port C, PC0 and PC1. I think it's better write it. Yeah, I think better write it PC1 and PC0. So that means PC1 is connected to S1 and PC0 is connected to S0. Okay, so this is about like that. So we have to write a program to operate the motor as follows. If these two switches are 0 0, then motor is off, and if it is 0 1, then single phase full step mode. Full step means like if it is a four phase system, 90 degree, 90 degree, 90 degree, full step. Actually this is the full step, but I mean from one step to another step it is 90 degree, and 1 0 it is not a single phase but two phase. Here two phase excited, single phase excited, two phase excited, actually. Yeah, anyway, it is same meaning. Again here also full step because 90°. But there is another mode in between, half step mode. So what is half step mode? Let us discuss this one. Then I will go to the program. Okay, so half step mode is, for example, if we have a B, C, and D. So four-phase stepper motor system, and it is about the angle theta. Okay, so if this one, so it will be, I mean, one phase and two phase. We have to operate the motor as a one phase first. For example, this one is, if A is 1, all are 0, it is in 0°. Okay, this is the reference axis is A phase. So, and then if it is 1, 1, if you can remember that A and B both are 1, then what is the angle? What is the angle? Step angle? What is the step angle? 45°, right? (45°). Then, yes, okay. And then B only. B is on. Just B is on only. B is on only. Then it will be 90°. Yeah, 90°. And then B and C on only. So it will be 135. 135°. Okay, and then C only. Then it will be 180. Then C and D. 315. Yes, okay. 315. Okay, and then just D only. Okay, so then it is another 45. So it will be what, as 45. So it will be 300. There is a mistake actually. I think there is a mistake you did. 0°, 45°, 90°, 135, then so 180. Okay, after 180 it's not 315. After 180 it will be 45, so it will be 225. 225°, and then 45 it will be 270. Yes, okay, no, it's fine. Okay, and then look at here, after D only, then D and A only. So then it will be another 45, so it will be 315. Now it is 315. Okay, and then again, so it will be just only D only. I mean A only. Sorry, D and A. Then now it will be A only. So if it is A only, then another 45. So it will be 360. So this is means 0°. So this is the same thing. So same thing is like the first one. So that means after here it will move to the next line. I mean here, or you can see from here it will move. It will repeat the things again and again. Okay, so That means this is called to half step. Half step means because in the previous, just for single phase, every time 90 degree, 90 degree. Okay, so okay, I am writing it here also again for single phase. A, B, C, and D. And what about the theta? So if A only, others are 0, it is 0 degree. Okay, if B only, all are 0, then 90 degree. And then C only, then another 90, it will be 270. 270, no, sorry, 180. 180, then just only D only. Yes, so it will be 270, and then repeat again. It will be 360. That means C on A again repeat. What about the two phase exit? This is for single phase. Okay, this is for single phase. Each time one phase on only. And if it is a two phase system, I mean two phase on system, two phase excited system, something like that. So okay, and if it is theta angle, so A and B on only. So this is already we have seen with the figure that it is in between A and B, 45 degree. Then B and C on only. Then another 90 in between B and C. So it will be 135. Then C and D, it will be 225. And then D and A on, then it will be 315. Okay, and then if it is again A and B only, so it will be 300, so 90 plus, so 400, 90, yeah, so 400, yeah, 400, so it will be 45 actually. If you added 90 plus 315, it will be 405. So 405 is 360 plus 45 is 405. So it will be 45 degree. So again it's repeat angle. So now look at here. This is a, so here it is a single phase full step, single phase excited full steps. It is for single phase on, single phase excited system, you can say. Here it is a two phase on at a time. So this is also full step because the step angle is 90 degree, and this one is half step. You know, this one is called half step mode or half step excited mode. Half step. half step mode. All right, so here actually what is the how can we get the half step mode? We have to operate it in a alternatively single phase and two phase, single phase and two phase. So this is the way we can get the half step. That means full step is 90 degree, half step is 45. So we will get the 45 degree for between two cases. I mean between for every time we are getting 40 half of the full step. That means 45 degree here. Is it clear? Clear here? What is single phase on mode or single phase excited mode? What is two phase excited mode? What is half a step mode? So this is about the basic idea about the stepper motor. Now, so our main purpose here is about how to write. Writing a program to control these things using switches. So what is the okay? Let me now. So I can erase it, right? I can erase the thing here. Okay, I think it will take time here. So let me erase it completely. Now it's about the program is defined. Okay, so I'm just writing the main control. Control is here, S1 and S0. They are the control switch. S1 and S0. So if it is 00, for example, if it is 00, motor is off. If it is 01, one phase, on, one phase excited system. You can. Excited. One phase excited. And if it is 10, it is two phase excited. Two phase excited system. And if it is 1, then it is a half a step mode. Okay, between one phase and alternatively one phase and then two phase, then one phase and two phase. So half a step mode, simply half step, half a step mode, we can say. Okay, so simply and what else? So stepper motor is connected to. So stepper motor, it is connected with port A, port A 0 to port A 3. So 4-bit, 4-phase stepper motor, it is connected to the port A. Okay, and the switch. So S1 and S0, S1 and S0, these two switch, they are connected with, for example, port C, PC1 and PC0. Okay, so it is like that, for example. So these two, shortly we can write it like that. And about the address, for example, addresses are given. So so this is about the things, and this is our control. We have to control it, and addresses. Uh, so addresses are port A, port B, this is for port B, and port C, and control register. So control register. So this address, for example, given, or if it is not given, looking the hardware connection, looking the circuit, we can find it. So so this is not the main thing about I mean about this exercise. So it's about writing the program to to control the operation of the stepper motor according to the switch condition. Okay, so problem is defined, right? It is clear. Okay, do you have any question here? No. Okay, so now it's about writing the code. So dot model small, then dot code. Here we can define like EA, EQU, 00H, EB, EQU, 02H, EC, EQU, 04H, control register, CR, EQU, 06H. For example, this is about, okay. Now about the control word. What is the control word? First of all, we can find the control word here. What is the control word? Control word. What is the control word? Okay, so now this one is for port C lower. Port C lower, here it is a switch connected to the switches, right? It is input. And port B, it is unused. And this is for mod 0.
and then port C upper, it's unused, and then port A. So this is connected to the motor. So motor, this is output, and then this 2 bit is for mod 00, and this one is 1. So it becomes, if don't care cases are 0, then it becomes 8 1 H, or don't care cases are, if it is 1, then 1 0 1 1 1 0 1 0 1 1 is B, 8B. Is it okay? Control word is okay? Here in this case, control word is okay. Anybody has a question? So tell me immediately, otherwise I will go to the next part. Okay, if control word, so then we write the move. Yeah, so let me finish the finish this class, because you know we have just this week and next week. So I think yeah, you have to think about that way, because otherwise how can I? Okay, so move AL comma control word. So control word is 80H. Not 80 actually, 81H. Okay. Out. So control register CR comma AL. So this is about the control word sent to the control register. Now it's about our main program. So start, because we have to repeat here again and again. Start. So now start. How can we start it? First of all, we have to read the switch condition. Switch condition in AL comma, where is the switch connected? Port C. So PC, port C address is 04H. We can write 04H, or we can write PC. We use a variable here. Now we will consider what are the condition of the switch. I mean, compare AL comma, if it is 00, if switches are 00 and all other bits are 0 also. So 00, if it is 00H, then it will go to the jump equal go to off. If it is not, then compare AL comma. So if S1 and S0 and they are 0 1, then all the MSB bits are 0. Okay, then what will happen? It will be 0 1, right? 0 1H. If it is a 0 1H, jump equal. If it is equal, then go to the single phase mode. For example, SP. If it is not, then compare AL comma. Look at here, S1 and S0. If they are 1 0, then it will be all our previous MSB bits are 0. So it will be 02H. If it is 02H, it will work for two phase mode. Jump equal to phase mode. If it is not, then compare AL comma. If S1 and S0, look at here, for S1 and S0, they are 1 1, and all the MSB bits on the left, they are 0, then it will be 0 3. 03H, if it is equal, jump equal,
We'll go to the half step mode. For example, half step mode. Okay, half step mode. Okay, now it's about or what is for off. So off condition is okay, very simple. I mean, because it is connected to the motor, 4 phases are connected to the port A 0 to port A. If we send move AL comma 0 0 0 0, all are 0 0 H, okay, simply 0 0 H out port A comma AL, then it will be off, right? And then again from here jump start, because we have to do it again and again, check the condition. Okay, then it is about the off, done. Then what about the single phase? SP, single phase mode. Mode AL comma single phase mode, you know, I said we have to send 11H. Okay, can you remember that one? Single phase mode, send 11H, and then out port A comma AL, then port A comma AL. Then what actually we have to do? We have to make a rotation. Rotation ROR, rotation, sorry, rotate left. Rotate left AL comma 1, then rotate left AL comma 1, and then jump L comma 1 and jump L. Jump L, where actually L is here, right? Yeah, so but you know that we have to write something, how many times we have to finish it here. Once we come to the single phase mode, we have to do the rotation 4 times, right? So move here, one more line, move CX comma 4 times. If it comes to the 4 times, I mean it makes the rotation 4 times, then it will complete. I think instead of jump we can write a loop, and I think that will be better. Loop. So this is about the single phase mode. And then what about for for okay, for a 2 phase mode? 2 phase. Okay, so out move AL comma 33H. Okay, and then we have to send the counter 4 also. Move CX comma 4, because we have to make the rotation 4 times, then it will be done complete. And then out port A comma AL. Okay, output A comma AL, and then here actually this one we have a label is, for example, here M. This label here M label.
Okay, and then rotate left L comma 1 and loop n. So that means it will be okay. And then once it is done, then what actually we have to do? We have to make the jump start. Here also jump and start. So this is about the off condition, single phase condition, and two phase condition. But what about the half step mode? So half step mode is, I mean, only the tricky part here is half step mode. So like half step mode, what actually we have to do now? Okay. So half step mode, we can write move L comma 11H. Okay, for single phase 111H, and move BL. We use not directly 33. We use BL comma 22H. So look at here 11H plus 22H. If you add them together, it will be 33H. So what actually we'll do? So and then out. Okay. So before. All right, so yeah, then okay, in the next class we will start about the half step mode. Okay, so from here, okay, it is done. Next class, so all right, okay, next class, from next class we will start just only we'll discuss about the half step mode. How can we operate the motor in half step mode? Okay.